Okay, my name is Ben Teese and I work for Shine Technologies, and I'm going to talk a little bit about Koa, which is a new sort of next generation web framework for Node. This talk's going to assume you know a little bit about Node and its callback model, and a little bit about promises, or the basic principles of them. But otherwise, it's going to build up from scratch a picture of how Koa works using the new ES6 and generators support that's coming up soon. Now, there's a couple of things that you should know about using Koa and even generators before we start. And firstly, you're going to need Node 0.11 for this stuff to work, and that's an unstable version of Node at the moment. Hopefully 0.12 will be out soon, but it's using a version of V8 that supports generators, which is why we need it. Second thing that you really need to know is that you're going to need to enable ES6 support when you run Node. To do that is really just a command line flag, the -- harmony flag that you provide to whatever app that you're running. Now, when I first started learning about Koa, I was really curious as to what was sort of going on under the hood, or at least how generators were making asynchronous programming so easy with Koa. So what I thought I'd do is start with the basics of what generators are, and then work through the Koa framework, which is sort of built with generators to bridge with promises, and then show how they are then extended even further to work with Koa and to provide sort of the special sauce that Koa needs to do its stuff. So let's start by talking about generators a little bit in detail, and these are something that is coming up in ES6, something that are already I think in Firefox and Chrome, and the version of V8 that's used by Node 11. So even if you don't do Node work, generators are something that's worth knowing about, because there's even some browser support now. And whilst promises can take you a long way towards cleaning up your asynchronous code, generators take you that extra step that eliminates callbacks completely in a lot of cases, or the need for explicit callbacks in a lot of cases. And you'll see that the end result is pretty amazing. So let's start with a basic example of a generator in action. This is just a little hello world program. The first thing you should know about it is that we're going to run it with the -- harmony flag. So let's see what happens and how we flow through it when we do that. This little Node script. The first thing to note is that we're declaring a generator at the top, and it's got this special syntax. We put a little asterisk at the end of the function keyword. We won't dig into the body of that generator quite yet. The next thing we'll look at is that a generator function you actually call, and it'll give you an object. And that's what you work with when you're interacting with a generator. So in this case, we've got a little hello world object that we're dealing with. So if we were to run this script, the first thing that's actually going to kick off and do something real is this point here. So each generator object has a next method on it. And when we call that next method, we kick off the generator. So let's dive into what happens. We're going to call next, and we're going to jump into our generator function. Now this is a pretty simple generator. The first thing it's going to do is immediately yield control. And what this means is that the flow of control is going to temporarily dive back out of the generator function again. So the next thing is that we're returning back to hello.next. Now the next method will return us an object, and it's got a couple of things in it, but the thing that we're interested in is the value, and that's the thing that was yielded up inside our generator. In other words, the string hello. So if we log that string as part of our running program, we're going to see hello logged to the console. Now the next thing that happens as our script executes is that we're going to call hello world next again, and the really interesting part is what happens at this point. We re-enter our generator function, but we re-enter on the line after the one that we previously yielded on. In this case, we're just going to immediately yield again with another value, the string world. Having yielded, we end up back at our call to hello world next. We take the value that's been returned and get it. If we log it out again, we've got hello world being logged to our console. Now I'm going to run through that again just with a couple of logs just to make it really clear what's happening. When we run our program, we call next on the hello world object. That enters the generator function, it yields up hello, and then it immediately returns. Note that the following console.log re-entered didn't get called yet. We'll get the value and log it, we see hello. And just to be 100% clear as to where we're at, we're going to log that we yielded. We'll call hello world next again. We re-enter at console.log this time, the line after the previous yield, which is pretty cool when you think about it. We'll log that value, then we're going to yield out the string world. It goes back, we pick the value out, and we log it. That's pretty cool when you think about it. One other important thing about generators that you should know is not only can you yield values up, but you can pass values back in when you return control to the generator. So in this case, we're going to call hello world.next as usual. It's going to do a yield on hello, or yield with hello. Now notice that it's assigning that to a variable, but we're not assigning it quite yet because the yield immediately exits the function. We'll get the value out, hello, as usual, and log it. Now the interesting part is what happens next. We're going to call next again, but we're going to pipe a value into it. That value will be picked up and assigned to received in this case, so our call to yield inside the generator actually returns something, so to speak. So now that the received variable has been set, we can log it. Now we'll yield out world again, pick the value out and log it. So hello there world. Now generators in and of themselves aren't really an asynchronous programming mechanism. They're more just an alternate way of doing control flow in a program. But where they get really interesting and useful from an asynchronous programming perspective is when you combine them with promises in particular. And promises are also something that are coming up in ES6. Now, they've been around in various other forms as well, jQuery, lots of modules like Q and so on. We finally picked a standard in ES6, and if you combine them with generators, you can do some really amazing stuff. And that kind of brings me to the first sort of library that we probably need to go into before we talk about Koa, and that's Ko. Now, Ko was invented by this guy. This is Hollowaychuk, a pretty prodigious contributor in the Node community. So prodigious it's even been speculated at times that he must be more than one person. Probably more notably, recently TJ kind of stepped back from the Node community to do a lot of his server-side work with Go, and handed over control of a lot of his projects that he had been working on, probably the most well-known of which is Express, which was sort of the original Node web development framework. However, there are a couple of projects that he has remained a little bit involved in, and they are Ko and Koa. So Ko is essentially a really small little library that acts as a mediator between generator land and promises land. More specifically, any promises that you yield up, it will automatically listen for the case that when they're resolved, and then re-inject back into a generator the resolved value that was provided by promise. So we'll just provide a quick little example here. Ko is just a Node module like any other, and it's really just a function that wraps a generator and returns a promise. In this particular case, what we're going to do is create a couple of promises of our own. We're using the ES6 promises API here, which might be a little bit different from promises you're used to seeing in, say, Angular or jQuery. We create a new promise object and we give it a function, and that function will be given another function that we can call when we want to resolve that promise. And we're just going to retain references to a couple of those resolve functions so that we can manually call them ourselves later on. The key thing here, though, is that these are promises. They could also, in the real world, be promises from triggering an XHR request or a timeout or something like that. So we're going to store references to those two little resolve functions. Okay, so as we execute the generator, and it does pretty much execute straight away when we put a co-wrapper around it, we're just going to yield up one of those promises immediately. Now, the generator pretty much then immediately passes control back out of itself. And what we're going to do is actually take the promise that co has given us and essentially wait until it's finished. We're going to put a then call on it, and when that promise is finally resolved, we'll log the result. However, it's important to note that that hasn't happened yet. Essentially, all we're doing at this stage is registering a listener for when the promise gets resolved. Now, further on down the track, say we want to resolve one of those promises, and we're going to resolve it with the string hello. So we're going to call our resolve function, and this is kind of when some of the magic happens. When we resolve the promise, the co-wrapper will will detect that the promise is resolved and will inject the resolve value back into the generator. And that's what we see here. We're going to assign that to 1, or result 1. We'll do the same thing with promise 2. We'll yield control out again. Co will detect that a promise has been yielded to it. It'll start listening to that promise or watching that promise. And then at some stage down the track, asynchronously, whatever, we're going to resolve that promise again. And this time we'll just provide the string world. As a result, resumes the generator again and returns the resolve value, which in this case will be the string world, and assigns it to a variable. Now we're just going to append the two values together and return them. The co-wrapper will essentially now resolve the hello world promise and pass that return value as the result. So what that means is that our console.log call will finally be invoked, and hello world will be printed out. Now, admittedly, this is a pretty roundabout way to write a hello world program here, and it's kind of unusual in the real world to write your own promises or to ever really call a new promise yourself. Normally, like I said, you'd use XHR requests to generate, triggering an XHR request would create a promise, or a timer would create a promise. So it's kind of unusual to do them yourself. The really interesting part here is that because co both accepts promises that are yielded and also returns its own promise, you can essentially compose things that are wrapped with co of other things that are wrapped with co. And that kind of brings us to the next part of the presentation, and that's Koa. So Koa is built upon the Co library, and it's a next generation web framework for Node. And it's regarded by some as being kind of a spiritual successor to Express, is one way that it's been described before. And it's not really, it hasn't become Express 5 because it's just too different from the way that Express works. And some of the philosophies are the same, but because the underlying control flow constructs are so different, it would be impractical to just treat Koa as a simple, or moving to Koa as just being a simple upgrade on the existing Express app. So let's start by looking at a simple example of Koa in action. We'll go with just serving up a file. Here's a really simple Koa program. Koa is just a module, like any other. Now, one interesting thing to note about Koa is that it doesn't even really include a router of its own. It's very, very small, probably 550 lines of code last I heard. Everything is done with modules, or specifically what's called middleware, which we'll talk a little bit more about in future. We're going to bring in our own little simple Koa router that's already out there in the world. There are more sophisticated ones, that this one will serve us well for now. We're also going to bring in a little file system, or Node, a file system API wrapper called Co-FS. This is essentially the Node file system API wrapped with Co so that it produces nice promises and so on that Co will work well with, and Koa will work well with. First thing we do is instantiate an app object, and we're just going to set up a really simple route, just like a route/route for our app. Note also that we're passing a generator to this thing. Before we get into the body of that generator, we we'll just start our app and get it listening on a particular port. So what happens when we try and go to this route? Well, the first thing is that our generator will get kicked off. And one cool thing you should know about Koa is that rather than having separate request and response objects, it sort of wraps them all into one object and assigns them to this, which is really handy and makes it really easy to manipulate those things. So the first thing we're going to do is just set the type of our response. Second thing that we're going to do is read up a file asynchronously, and because we're yielding on the promise that we get back, or yielding on what we get back, all of that processing will happen asynchronously. When it is finished loading, our generator will be re-entered and we'll assign the result to this dot body. And that's a really simple example of Koa in action. It's handling incoming calls asynchronously and reading files asynchronously, yet without any callback craziness. Let's pick an example that's a little bit more complicated. Say login. We're going to bring in a couple more modules in this case. The first one is this co-body module, which is really just used for parsing incoming request bodies asynchronously. And we use a database. In this case, we use RethinkDB. So say that we want to create an endpoint for creating a new session, which is essentially just the same as logging in. We'll make it that the credentials for logging in are being passed to it as JSON. When this endpoint gets triggered, the first thing we're going to do is parse the request that's come in and get the body out of it. Notice that this is an asynchronous operation. When that operation is finished, we'll be making a call to our RethinkDB database just to fetch a user that has a particular username. Again, this is an asynchronous operation. Assuming that both of those operations are successful and have re-entered the generator, we'll get the first user out, kind of assuming there's only one here. We'll then check their password. Now, obviously this isn't security best practice. We normally wouldn't be storing plain text passwords in a database, but it'll do for this example. If everything matches up okay, we'll just set a status code, and that's all that we really need to do. The client will get a response code of 200. In the event of things not matching up, we'll just raise a JavaScript error and assign a status property to it and throw that onwards. And Koa will pretty much handle converting that thrown exception into a response and so on. So I guess the cool thing about all of this is that, again, it's doing some asynchronous work, but there's no callbacks involved. And furthermore, we're able to start using traditional control flow mechanisms, like exceptions, for example. Now, I kind of alluded to this earlier, but it turns out that Koa is really small and is built entirely around the idea of having small composable middleware components that you can put together however you want. And importantly, they are quite easy to write using generators. Certainly easier to write than middleware for Express, where the callback model can get really tangled up, especially if you're trying to do error handling correctly and things like that. So I'm going to give you an example of your own custom middleware being built, and I'm going to pick a topic or an example based on a topic that is certainly something I'm pretty excited about, and that's JSON Web Tokens. These are just little signed JSON fragments that you can pass between a client and a server. They're signed so people can't mess with them. You can put whatever you want inside them. They eliminate the need for server-side state, which has a multitude of benefits. They're kind of like signed cookies, but without sort of the baggage that comes with cookies. Clients that aren't browsers, mobile apps and so on, native mobile apps can use them. I'm pretty excited about JSON Web Tokens, so I just thought I'd use these as an example. The first thing that we're going to do is tweak our session creation endpoint slightly. In addition to checking the password and so on, we're also going to set a header on the way out, and that header will just be a JSON web token. So we're going to bring in a JSON web token node framework, node module here, and the next thing we're going to do is add this line, sets a header, just a custom name. The header is a signed token. It's signed using a server-side secret. It always stays on the server side, so it means that things can't be tampered with, essentially. Tokens can't be tampered with. We're going to put the user ID into the, or the user's ID into that token. Because it's a header, it will essentially be returned to the client. Now, the assumption here is that the client is smart enough to, and it could be a single page app or a native app or whatever, it will look at response and pick that token out of the header, and it will remember that token. If it was a web app, it might store it in local storage or something like that. And then on any subsequent call, it will add that token as a header on a subsequent request. So how do we sort of check those requests? And that's where middleware comes into it. We're going to define our own middleware here that basically checks that the tokens are valid that are coming in. First thing is that we're just passing a raw generator into app.use. That's essentially how you define middleware with Koa. Everything's middleware at the end of the day. First thing our particular piece of middleware is going to do is just have a quick look at the URL. We don't want or need to protect just the root URL or /session because those are unprotected paths. However, anything else we want to protect. So if the URL isn't either of those things, we will extract the token from the incoming request. Then we will attempt to verify the token. Now, you may notice here that I'm actually passing a callback into this JWT verify method. And that is an interesting thing to talk about because JWT is a Node library and it's designed for use with traditional Node apps, and as a consequence it works with callbacks. And furthermore, it doesn't return promises or anything like that. It's pretty old school. So, how do we deal with that in the context of a Koa app? Well, the good thing about Ko is that not only can you yield up a promise or yield a promise out of a generator that's wrapped with Ko, you can also yield what's called a thunk. And a thunk is basically a function that takes a node style callback, and it will deal with that in a similar sort of way. It'll see if the callback is invoked with an error, and if it is, it'll raise an exception, and if the callback is invoked with a value instead, then it will just return that value. So in this case, we're wrapping the JWT verify call in a thunk of our own, and we yield that up. When control returns to the generator, we'll be given the payload that's been created here. What we then do next is just take the user ID out of the payload, and we're just going to assign it to this. Now, in the event that the token isn't valid, it's come in, say someone's tampered with it, or something like that, JWT verify, as I mentioned, would call the error, would invoke the callback with an error. Ko transforms that into an exception and throws it out of the yield. So in that case, we just catch a regular exception. We'll just set a status on it and then throw the exception onwards, and Ko will pick up the exception, and stop flow won't let the request propagate any further into the app and return that status code to the client. Now, because this is middleware, the next thing that we do, assuming that either there wasn't a problem with the token or we just weren't going to a protected endpoint, the next thing that we do is yield to this next argument that's been provided to the middleware. And that'll mean that any downstream middleware or any other pieces of middleware that have been that are being used with the app will be invoked. And that includes, for example, our router and so on. If I don't call next, then it won't get invoked. Another just token thing that I put on the end here is just an additional console log, and the reason that I put that in is that middleware can kind of be composed Russian doll style. So once any downstream middleware finished executing, control will come back to our little JWT checking middleware. So I can do a log or do whatever I want, or I don't have to do anything, but it's important to realize that you have the option of intercepting both before and after calls to downstream middleware happen. So that's an example of middleware in action. What it means is that, say that we've got some other endpoint, say an accounts endpoint that we're declaring here, it'll be protected. If there isn't a valid token attached, then this endpoint won't be able to be reached. Furthermore, if a valid token is detected, the middleware will have pulled the user ID out of it and just attached it to this context so that we can then use it in our downstream endpoints. In this case, we're just going to use the user ID to look up some other information about the user, which is all pretty cool. Now, yeah, in case you haven't guessed so far, Koa is essentially all about middleware and having lots of small composable pieces to put together. And there's lots of them out there already. In this talk, I've shown you how to write your own middleware, but frankly, I think that you could go a long way with Koa without having to write any middleware of your own at all. So a couple of examples of middleware that's already out there. There's logger middleware that will log calls as they come in, before and after a route's been processed, for example. There's middleware for tracking response times and so on of calls and how they've been handled. There's even middleware for more complex things like integrating with Mongo, with connection pools, connections per request, things like that. So that kind of wraps up my intro to Koa. I think a key message to come out of it is that this generator stuff is really awesome and provides a really good way to streamline your code. And generators are happening, they're in this unstable version of Node, they're in Firefox and Chrome. This is, the next iteration of JavaScript is going to use these things, and they make asynchronous programming much easier. Plus, when they're used in conjunction with something like Co and promises, they give you a path, a pretty clearly defined path to async functions and stuff like that, which are coming up in ES7. And async functions will actually completely eliminate the need for things like Co. I think one other great thing about Koa in particular is that it's just nice to have boring code again. Although this stuff is asynchronous, you shouldn't have to get bogged down in a maze of callbacks. It's great to be using regular control flow techniques again. When you do coroutines with Koa or Co, it's not exactly the same as pure imperative code, but it's a lot closer than if you were using callbacks. So I hope you've enjoyed that talk. Get out there and learn about generators. There's some great material out there about them. And if you're thinking of starting a Node server-side project from scratch soon, I would take a serious look at Koa over Express, because I would consider Koa to be far more future-proofed and frankly easier to work with and more productive. Thanks very much.